In this video for section 3.1, we're going to look at the graphs of quadratic functions and their minimum and maximum points. So this graphic here comes from the book, and it shows two parabolas or quadratic functions, and it identifies some key terms. The first is vertex. The vertex is the minimum point on a parabola or the maximum point, depending on whether it opens upward or downward. If a, which is the number in front of x squared, is positive, then it will open up, and the vertex will be a minimum point. If a is negative, then it will open down, and the vertex will be a maximum point. We also have what is called the axis of symmetry, which is a vertical line that goes through that vertex or minimum point. And you can see that the parabola is a mirror image on either side of that axis of symmetry. So we're going to start by looking at quadratic functions in what is called vertex form. So we have this function, y equals x plus 3 squared plus 1, that we're going to graph on the Desmos graphing calculator. So here's my graph. The first question is, what are the x-intercepts of the graph? Well, I can see from looking at the graph that the graph does not cross the x-axis. So there are no x-intercepts for this graph. My second question is, what is the y-intercept of the graph? While looking at the graph, I'm going to need to move it a little bit to see the y-intercept. I can see that the y-intercept is at 10. If I wanted to write it at a point, that would be 0, 10. Question 3 says, what are the coordinates of the vertex? And how is the vertex related to the equation? So I can see by clicking on the vertex that the vertex is -3, 1. And when I look at my equation, I see the numbers 3 and 1 in my equation. So the 3 is contained inside the parentheses with the x. The x-coordinate of my vertex is -3. My y-coordinate of my vertex is 1, and that is outside of the set of parentheses, plus 1. So the coordinates of the vertex are found within the equation. The x-coordinate is inside of the parentheses. The opposite sign. And the y-coordinate is outside of the parentheses with the same sign. Question 4 says, is the vertex a maximum or minimum point? So since our parabola is opening upward, the vertex is the minimum or lowest point on the graph. Question 5. The axis of symmetry is a blank line that goes through the blank. It is a vertical line that goes through the vertex. If the coordinates of the vertex are h, k, the equation for the line of the axis of symmetry is blank equals blank. So this is a vertical line, and it's going through the x-coordinate of the vertex. So looking at my example here, the axis of symmetry would be a vertical line going through -3. So that means the equation would be x equals -3. So for this graph, it's x equals -3. If the coordinates of the vertex are h, k, then the line for the axis of symmetry would be x equals h. So whatever your x-coordinate of your vertex is, the axis of symmetry is x equals that number. add that to my graph here. X equals -3, just to check that it's the correct equation, and I can see that it is, because that blue line is the axis of symmetry for the parabola. Are there any x values that the graph does not cover? The answer to that is no, and we don't see all of them here, obviously, but the parabola is going to continue. For any value of x, I could plug that into the equation, and I could get a y value. X could be positive, it could be negative, it could be a decimal, it could be a fraction. There are no limits on what numbers I can plug into the equation, and all values of x are going to be represented on the graph at some point. So the answer to this question is no. There are no values that the graph does not cover. So for the domain, there's a couple ways I could say this. I could say that the domain is all real numbers. I could also use interval notation. And the way that I would do that is I would use parentheses. This is going from -infinity to +infinity. Actually, I'm going to write this with my tablet. It's a little bit easier. You can find the symbols on Word as well, but it'll be a little bit faster for me to write. So -infinity to +infinity. This is called interval notation because the interval tells us what the lowest and highest numbers are. In this case, they're not numbers, they're infinity. When we use infinity in interval notation, we always use the what's called the open bracket or the parentheses around infinity. When we're dealing with numbers, then the open bracket means the number itself is not included. But for infinity, we always just use the round bracket. Question 8 says, are there any y values that the graph does not cover? So looking at my graph again, I can see that the graph, in terms of the y-axis, the graph is covering all values down to 1. Once we get lower than 1 on the y-axis, there is nothing on the graph there. So the graph is covering all values greater than or equal to 1, does not cover anything less than 1. Because this is a point here on the parabola, this -3, 1, then that is included in my domain. Or sorry, in my range. So what is the range of the graph? The range of the graph is all values greater than or equal to 1. The way that I would write that in my interval notation would be like this. Switch back to my marker. I would use a square bracket. You can find the square bracket on your keyboard. We're going from 1 all the way up to infinity. So 1, infinity, open bracket around infinity. So this is saying everything from 1 up to infinity, including 1, because I have the square bracket around 1. Infinities always use the round bracket.